We've spent the last 2 lessons talking about how to count the number of ways things are possible to happen. And that included the fundamental counting principle, permutations, and combinations. Today we're going to talk about how students can find theoretical and experimental probabilities. A couple definitions here, or one definition here. The probability of an event is a number between 0 and 1 that indicates the likelihood the event will occur. An event that is certain to occur has a probability of 1. An event that cannot occur has a probability of 0. An event that is equally likely to occur or not occur has a probability of 1/2 or 0.5. And there's kind of a line here to show you kind of where that fits in from 0 to 1. Theoretical probability is when all outcomes are equally likely, and we can calculate the probability by taking the number of outcomes and divide by the total number of outcomes, and it's often simply called the probability of the event. Okay, so if you are familiar with dice, dice is actually plural. 1 is just called a die. 6 sides are numbered 1 through 6. We're going to find the probability. Okay, so if we have the options 1, 2, 3, 4, 5, and 6, we're going to kind of look at that. Those are my 6 sides there. The probability of rolling in an odd number, there are 6 possible options. There's 6 sides, 6 numbers. And 1, 2, 3 of them are odd. So the probability of rolling an odd number is 3 out of 6, or 1/2, or 0.5. Okay, make sure you reduce your fraction or give me a decimal. For part B, the probability of rolling a 4, okay, 6 possible outcomes. How many 4s are there in that option? In our options, well, there's only 1 4. So our probability of rolling a 4 is 1/6, which you could also change to a decimal if you want. Okay, and then the probability of rolling a number less than 7. Well, there's 6 total outcomes possible, 1, 2, 3, 4, 5, 6. And actually, in this case, all of them are less than 7, so all 6 of them are included, so we get a 1. So remember from the previous slide that if it's guaranteed to happen, we have a probability of 1. So that's guaranteed to happen. Next option, you choose a playlist on your phone that has 8 songs. You select shuffle and do not repeat the playlist. What is the probability that the songs are played in the same order that they are listed on the playlist? Now we need to know first how many possible ways could they be played. So think back to our last couple lessons. 8 factorial, 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, is the total number of possible outcomes. So 40,320 different sequences or orders that they could play the songs in. And since we want it to be played in the same order that they're listed, that's one specific order. So our probability is 1 out of 40,320. For the next one, same situation. We have 4 favorite songs on the playlist. What's the probability that 2 of them are played first in any order? The order does not matter, so I'm going to use a combination here. And I have 4 songs and I'm choosing 2. So 4 choose 2 for combinations gives us 6 when you type it in your calculator. So remember in your calculator, you hit the math key, go over to PRB or PROB, depending on the calculator you have, and go down to NCR and then type your numbers in. The total possible outcomes, well, we have 8 total songs, and we're choosing the first 2. So again, use your calculator. 8 choosing 2 gives us 28. Then we just need to reduce this or to divide it to make it a decimal, which is fine. And we have our answer there. Okay. So theoretical probability is just kind of looking at the situation and predicting what could happen if they're equally likely. Experimental probability is when you perform an experiment, conduct a survey, or look at the history of an event to calculate the probability. So this would be actually like rolling a die 6 times to see what you get, and calculating your probability then. So it's kind of like an actual probability when you try things out. you're going to use when it's not possible or convenient to find theoretical probability of an event. And for ours, a lot of times we're going to be given some type of table or information there. Okay. So, last example. In 1998, a survey asked internet users for their ages. The results are shown in the bar graph. Find the experimental probability that a randomly selected internet user is, at most, 20 years old. Okay, first thing I'm actually going to do is, these are all our totals for each of those age ranges. I'm going to go ahead and add those together to get a total of 12,443 people. This is our total for our problems that we're doing here. Okay, so it's going to be the bottom of our fractions, 12,443. And then at most 20 means that they're under 21. Okay, so at most 20 means they're under 21. We need 1,636. And I'm actually going to divide this because it's not a nice fraction there to reduce. And I get 0.131 for the probability. So if you selected somebody at random in this group out of the 12,000 people, it is not very likely in this survey that the internet user is under 21, or at most 20. Now keep in mind, though, this is a really old survey. Okay, good for a laugh because most of you, actually all of you, weren't born yet. Okay, next one, at least 41. So again, we have 12,443 total people. At least 41 would start here. So at least 41 includes this group, and this group. So if I add 3,693, 491, and 6 together, I get 4,190. And if we divide it, we get 0.337 for our probability. So that's a little bit closer to being half. Okay, take a minute. There are a couple guided practice problems here. I want you to try those, see how you do. Check them. Let us know if you have any questions. And if you want, you can hit pause. I'm going to go ahead and write the answers up here.